The odds against a particular event happening. So odds against happening means this is happening and this is not happening, because odds against whatever it is happens second. So what's the probability the event will happen? 6 out of 15, which is 0.4. And then it usually went a little more downhill from here, but that was pretty good usually. A high school football coach is trying to decide what quarterback he should start in next week's game. He examines the win-loss ratio for the two quarterbacks. Which quarterback should he start? Convert each win. Quiet, please. No, not a chance. Yeah. No. Okay. So we need to do the probability of winning for Jermaine. Winning for Jerem. 8 out of 13, which, when you round it, is 0.62. For those of you who are rounding, or 0.62, sorry, or 62%. For those of you who rounded that to 6.1, stop. Round properly. You wouldn't get it right if it was on the diploma, and that was the actual answer you had to put in. Yeah. That's what I did.
Yeah, but I got 61%. I didn't round.
That's because your rounding is bad.
I didn't round, that's what I got.
Adrian, put 8 divided by 13 into your calculator. I can't believe we're recording this right now. All right, and it's 62. Probability of win, Gabriel, is 7 out of 11, which is 0.64%. 0.64 and 64%. For those of you who put 63, stop. Look, decide you should round up and undo what you did, because 63 is not correct. So Gabriel is the answer.
So if you were marking this.
The probability that Elvin's mother will serve rice with dinner is 0.78. So probability of serving rice, 0.78. Probability that she will serve carrots, 0.30. Neither rice nor carrots, so probability of neither, 0.14. Draw myself a Venn diagram. There shouldn't be a cell phone out. Rice, carrots. So 0.14 would go here. How do we figure out what goes in the middle? Well, we know that there's 0.86 left, because every Venn diagram has to add up to 100 if it's probability, or 1 if you do decimals with probabilities. If you're doing percents, it has to add up to 100. If you're doing decimals like I am, it has to add up to 1. So I have 0.86 left for the middle. If I take the two, rice and carrots, and add them up, I'm left with 1.08. Well, I only have 86 left. So if I take 1.08 and I subtract off 0.86, I'm left with 0.22. That must be in both. So you'd have to have 0.22 here. And then you'd go 0.78 minus 0.22, which is 0.56. And then you do 0.30 minus 0.2, which is 0.08. So that would be your Venn diagram that would get you a mark. Determine the probability that they'll serve anything other, I guess, either both rice or carrots. Holy, that was hard to say. It's 0.22 or 22%. I'd accept either of them. Now, on the diploma, if it says to the nearest hundredth, and that's all it says, it just says to the nearest hundredth, your answer would be 0.22. If it says to the nearest whole percent, your answer would be 22. You can't give percent unless it says to the nearest something percent. It has to say percent, or you leave it as a decimal, okay? Or you're wrong. Each of these are worth 1. So like A was worth 1, B is worth 1. Jessica's playing a game of solitaire using a well-shuffled deck of 52 cards. If she lays 7 cards face up, so this is all before probability. She has 52 cards, 7 cards face up. Those rules are for the top and the bottom of this probability solution. Okay, 52, she's flipping up 7 of them. Okay, top and bottom uses that. Now, after the word probability, this only affects the top. So the probability that there will all be spades only affects the top. Okay, anything that comes after the word probability. So we go probability of spades. I guess 7 spades. So on the top, how can I guarantee myself getting 7 spades? And I know I need to have 7 cards because it said I flipped 7 cards up before probability. So both the top and the bottom has to have 7. Yes, 13C7. And it's C because cards are always C. It's a combination, so you choose them. On the bottom, you use all of the information except for the stuff after the word probability. So everything up here, 52 cards, 7 of them face up. So it's always total no restriction. So what would be on the bottom? Yeah. So you would get 1.28 times 10 to the negative 5 I'd accept, or I'd accept 0.0013%. Number 5. A child randomly arranges 10 different books on her bookshelf. So this is information for both the top and the bottom because the word probability has not came yet. So she's arranging 10 different books. Some of you really thought she arranged 3. Some of you read the words of the titles wrong and thought she arranged 4, but she didn't. So she arranges 10 books. So that's before the word probability, right? So she's going to arrange 10 books on the top, and she's going to arrange 10 books on the bottom, not 3 and 10. She can't do that. So she's arranging 10 books on the top and on the bottom of your probability because that comes before probability. Now here's the word. What's the probability? So anything after that word probability only affects the top, only affects the numerator. That the cat in the hat, 1 book, green eggs and ham, 2 books, Horton Hears a Who, 3 books, will be placed together. Placed together. Does it say there's only those 3 books? No, we're still rearranging 10 books, but that only affects the top. So the 3 books are together. I'm just being lazy and not writing out the 3 titles. Okay? Together. Does together mean at the front? Does together mean at the back? Together just means together, right? So, how do we do that when it would just be a normal perma column question? 5, 6, 7, 8, 9, 10, all over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So on the top, we have that the 3 books have to be together. So did it say in that order or just together? Okay, so how many options do I have for the first blank? 3, then how many? 5, 4, 3, 2, 1. Am I done? What do I have to remember to do? Times it by 8. Because it doesn't say together at the front, it just says together. So they could be together here, which is one way. 2, 3, 4, 5, 6, 7, 8 more ways, right? So I have to times it by 8. I'm just putting it here because I've run out of space. Actually, I can go like this. On the bottom, what I'm going to have? Everything before the word probability. So the only stuff that's before probability is a child randomly arranges 10 books on her bookshelf. How can I arrange 10 books on my bookshelf? How many for here? 10 factorial. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it's going to be 8 factorial, 3 factorial, over 10 factorial. And I can say 8 factorial because it's 8, 7, 6, 5, 4, 3, 2, 1, and then 3, 2, 1 for the 3 factorial. When I do that, I get 0.067 or 6.7%. So all of it's out of one mark. Mark properly so you know how well or how not well you did. Okay, a card is drawn. So this is where people get a little bit mixed up. A card is drawn. So they're like, is it replaced or not? That's what people do. Is it replaced or not? A card is drawn. Does it matter if it's replaced or not? I just drew a card. It matters if it's replaced or not if I draw this card and then I draw this card with the word and in between, because then I'm drawing 2 cards, right? Then it matters if I'm replacing it or not. But I'm not drawing 2 cards. I'm drawing 1 card. When it's 1 card, It's one event. And when it's one event, they're either mutually exclusive. It's either mutually exclusive or not mutually exclusive. Okay, so I have one thing happening. I'm drawing a card, and then I'm asking you, what's the probability that this card in my hand is a red jack or a 10? Red jack or a 10. So or is under that mutually exclusive, not mutually exclusive column, right? Mutually exclusive, not mutually exclusive column. So I have to decide, how do I decide if it's mutually exclusive or not? Is there overlap? Is there overlap between the red jack or a 10? No. So if there's no overlap, I use the not mutually exclusive formula, which is the probability of a red jack or a 10, which is just the probability of a red jack plus the probability of a 10. If they were not mutually, if they were, sorry, these are mutually exclusive. I don't know why I put an N there. They're mutually exclusive. If they were not mutually exclusive, I'd subtract where the red jacks and the 10s overlap, right? I have to remember to subtract off the probability of red jack and a 10. But I don't have to because these are mutually exclusive. So how many red jacks are there? Out of 52. How many 10s are there? Out of 52. Some people put 51. They're like, because now I have one less card. I don't know if they replaced it or not. Ors, it's always going to be out of the total. The previous event doesn't affect the next one, right? They're occurring at the same time. I'm asking you, I pulled this one deck card out of the deck and I'm holding it in my hand. And what is the probability that this card in my hand is a red jack or a 10? Not pulling out a red jack and then pulling out a 10, right? I'm not saying there's no and in there, it's or. What is the probability that this card in my hand is a red jack or a 10? Right? Not and. I still fell. So that's 6 out of 52. Now, second thing. It says round it to the nearest hundredth. Does it say hundredth percent? No, it wouldn't even fit in there if it was hundredth percent. So if you actually put this in as a percent, you would get this wrong on the diploma. It's 0.12. So if you put 12, you would be wrong. As it says hundredth. It doesn't say percent at all, right? So it's 0.12. Now, I've seen some people do this. I saw some people do this. Seen doesn't make sense. Anyways, I saw some people do this. They circled in the 0. They circled in, the 1. They circled in the 2. The decimal, the 1 and the 2, and they left the 0 out. What is the machine going to do for you? It's going to mark you wrong. Because the machine accepts only these. Filling in the bubble is a better idea for you because, for this it didn't matter, but if you don't fill in the bubbles, you're not going to notice that this can't be a decimal. This spot cannot be a decimal. Why can't this spot be a decimal? There's no decimal bubble. I would tell you fix it. Don't do that. No. Diploma would though, because you actually wouldn't be able to find a spot to put your dot, right? That's why circling the dots is important because it gets you to catch that you can't have that first one be a decimal. So 0.12 would be the only thing accepted on that diploma answer. Okay, B. I have one card in my hand. What is the probability that it's an even card or a black card? Even card or a black card? Mutually exclusive or not mutually exclusive? Why? Because there's some even black cards. If you can say there's even black cards, it's not mutually exclusive. Not mutually exclusive means I need to use the probability of an even or a black card equals the probability of an even plus the probability of a black card minus the probability of an even and black card. Now, why is that? Because you're going to count the even black cards here. You're going to count the even black cards here. So you've counted them twice. So you have to take them off once. Yeah? Okay. So the even cards are 2, 4, 6, 8, and 10. Of how many suits? 4. So there's 5 of 4 suits. So there's how many total? 20 out of 52. What if I replace it? You'd be like, what are you replacing? You have one card. You're just asking what this one card could be, right? Blacks. How many blacks? 26 out of 52. How many evens and blacks? There's 20 evens. half of those are black. So how many even black cards are there? 10. There's 20 even cards. Half of them are black, right? So there's 10. So you're going to get 36 out of 52, which is 0.69. If you have any other answer other than 0.69, you are not correct. If you put it as a percent, you got it wrong. So that's why whenever there's an or, you have to ask yourself, mutually exclusive or not, correct? Because if you don't ask yourself if it's mutually exclusive or not, you're not going to catch that there was overlap and you need to subtract them if they're not mutually exclusive. Okay, next page. You were supposed to fill in the bubbles, yes.
No, it's time for some multiple choice.
Yes, it is. Okay. So the lunch menu at Mel's Diner allows you to choose one sandwich, one drink, and one cookie for the price of $5.49. The choices available are shown in the table below. If all possible choices are equally likely, then the probability of choosing a meat sandwich, how many meat sandwiches are there? 2 out of 4. And milk, 1 out of 3. And oatmeal cookie, 1 out of 3, is 2 out of 36, or 1 out of 18. A committee of 6 students is selected from 5 boys and 6 girls. Have I read the word probability yet?
No.
So this is all important for both the top and the bottom. Okay? So no matter what, we need to have 6. We need 6 people, right? No matter what. The probability that there are, so now this is for the top, the probability that there are exactly 2 boys. So people will go probability 2 boys. And then they're going to go 5C2, which I think is B or D, both of which are incorrect. How many people do I need for the top and the bottom? 6 students. So I need 2 boys and 4 girls. So on the top, I'm going to get 5C2 times 6C4 over the bottom. The bottom is all the green rectangle. A committee of 6 students from 5 boys and 6 girls. So what am I going to have on the bottom? Which is C. The bottom one I know is a little more difficult, but I'm going to show it to you anyways. So we have to decide if they're mutually exclusive or not. If they're mutually exclusive, the formula for mutually exclusive is P of A or B equals P of A plus P of B. So we're going to get 0.68 equals 0.2 plus 0.6. 0.68 equals 0.8. Is that true? 0.68 equals 0.8. Is that true? No. And this is not mutually exclusive. So these 2 are out. So I'm down to 50-50. The only thing I know is the not mutually exclusive formula I can use because I know it's not mutually exclusive. So not mutually exclusive formula is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And then fill in what I do know. I know the probability of A or B is 0.68. I know the probability of A is 0.2. I know the probability of B is 0.6. I have no idea what this is. So now I can solve for that though. I get 0.68 equals 0.8 minus P of A and B minus the 0.8. And I get negative 0.12 equals negative, this is the negative, P of A and B. Divide by -1, and these become positive. So now I know that P of A and B equals 0.12. So if it's independent, Then if I multiply P of A times P of B, I should get 0.12 because P of A and B is 0.12. Yep, 0.2 times 0.6 equals 0.12, so it's independent. So it's not mutually exclusive and independent, which is C.
I got it. I did it, Miss Lepp.
You guessed. Okay. Okay. Okay, multiple choice 10. In a recent survey of grade 12 students, it was found that 76% took math, 62% took bio, 93% took math or bio. Then the percentage who took bio and not math. So we know 93% are in the snowman. So we know 7% are out. Now, I need to find the overlap. So there's 93% in or, but I have 76 and 62. 76 plus 62. 138. So there's 138 for that whole circle, the two circles. But what do they tell me there's only left? 93. So if I subtract 93, then there's 45 that are overlapped. So I have 45% in here. Math is 76 total. So that's 21% just math. Bio is 62% total. So that's 17. So bio and not math, 17. Multiple choice 11 is a harder version of a question that I would normally give. Okay. I'm going to do multiple choice 11 as the easier version. So, we're going to pretend, because this is how you probably treated it, if Nicholas the president must be selected, we're going to put that after the word probability. It makes a difference, trust me. So, out of 10 students on the student council, 4 are to be selected to plan a school assembly. So we have 4 people that have to be selected, right, of the 10. That's top and bottom, correct? There are 4 males and 6 females, still top and bottom because the probability word hasn't came yet. Then it says, what's the probability if Nicholas the president must be selected, that 2 males and 2 females are selected? That makes a difference if Nicholas comes after or if Nicholas comes before. If Nicholas comes after, he's included as one of those 2 males. If not, he's not included as one of those 2 males. So we're going to treat him like he came after. So on the top, we're going to have the probability of Nicholas and 1 more male and 2 more females, because I'm pretty sure that's how you treated it. So 1 choose 1 gets you Nicholas, and then 3 choose 1. Why'd I do 3? Because there's 3 males left. Choose 1 because I already have 1 male in Nicholas. And then 6 choose 2. Yeah. Right. And then on the bottom, what am I going to have? Shh. Bottom, what am I going to have? 10 choose 4. Now, normally, if we do it the other way, you guys, if Nicholas president must be selected, then it's going to knock the top group down to only like needing 3, just like we had here. But the bottom would be 9 choose 4. It changes the whole dynamic. So we'll keep it like this. I don't know what this one reduces to.
5/14. I think we got it wrong. I guess. I did my own version of it and it worked out. That doesn't make any sense. Yeah, if you're smart enough guy. Oh, what? No, actually, it didn't do me.
These ones most people did really well on because they're not very hard. The probability of the complement of m, so it's everything that's not an m. There's 5 dots that are not an m, including this one. You have to remember to keep that one. So it's 5 out of 12. Probability of m or n is all the dots in the snowman. There's 11 dots in the snowman out of 12. This one is one of the easier ones, but you had to read the top sentence. Remember, you have to read everything in the question. So all of the 115 students brought at least, it should say one of the following items, not on of the following items, which is fantastic. So there's none inside the square, but outside the circle. So we have sandwiches, cookies, lemonade. Okay. So there's 5 who got all 3. 24 brought chips and lemonade, so that gives me 19 here. 27 brought sandwiches and lemonade, which is fantastic. 22. And 12 here. And then 54 sandwiches, so you add them up and subtract them and you get 15. Now, go 115. What's up? No, it's 22. Then you do 115. No, that is. 115, and you subtract all these from it, and you get 18. Okay. Totally. Use the word kitchen. Shh. Determine the number of ways.
Got it wrong.
I picked this word. No, it wasn't. So that the word didn't have any double ups or triple ups. So if it has double ups or triple ups, please remember you need to divide by those, right? So using the word kitchen, determine the number of ways the vowels must be placed together. So 1, 2, 3, 4, 5, 6, 7. A whole bunch of you on the test, watch yourselves, because once we start getting tests where I have them all mixed up, this one doesn't have the word probability, right? So I don't have to divide it by anything because there's no word probability. I just find the word kitchen and vowels together. So if I put the vowels together, there are 2 of them. I'm going to hook them together. 2, 1. And then I have 5, 4, 3, 2, 1. And then I times it by 6. So it's 1440. Now, B says it can start with a K and an A, not necessarily in that order. So some people think that the first letter needs to be K or I, not A. I don't know why I said A. K or I. But if the first letter could be K or I and that was all, then not necessarily in that order wouldn't make any sense. So the first 2 letters can be K or I, but not necessarily in that order. So 1, 2, 3, 4, 5, 6, 7. How many options? Then 10, 5, 4, 3, 2, 1. 240. Okay, the next one, a lot of people found hard, but it really isn't a hard question. You have to remember to put brackets around anything that's attached by plus or minus signs and life gets better. So I have 10x plus 4 over 5x minus 1. Please be quiet. Times x minus 1 over 35x plus 14. So 10x plus 4, you can take a 2 out, and you're left with 5x plus 2. The 2 doesn't just evaporate in thin air and go away, which it does with some of you. It stays. 5x minus 1 is 5x minus 1. You cannot take a 5x miraculously out of that and get it to be x minus 1. The only way you can get this to be x minus 1 is if this was 5x minus 5, I could take a 5 out and I'd be left with x minus 1. It is not. It stays that way for life. There is nothing you can pull out of it. 5x minus 1 will never be x minus 1. They are not going to cancel. Your problem sometimes is that you guys want it to be more simple than it can be. Okay? Now, x minus 1 is x minus 1. The bottom, I take out a 7, and I'm left with 5x plus 2. That 7 doesn't just evaporate. It has to stay there. The only thing that cancels is the 5x plus 2's, and I'm left with 2x minus 1 times 7, 5x minus 1. If you are the human being who thought leaving it in this step with the crossed off things, Mrs. Lepp, you can figure out how to put the rest together and give me a mark. No. This is the actual answer. If you are this person who crosses those out and thinks that I can miraculously make the final answer for you, that should be in the boxed version, you're going to lose marks. Okay? You're also not going to find this version on a multiple choice. Okay? There's not going to be the version with the crossed out answers as A, B, C, or D. So if there's not going to be that version of A, B, C, or D on your test, I don't want that as my answer from you guys either. So that's 1 mark. B. Yep. Yes. B, you have n plus 1's in the denominator. So I have to times this one by n plus 1 over n plus 1. So I'm going to get 2 over n plus 1 equals 8 over n plus 1 minus 3 n plus 1 over n plus 1. So you get 2 over n plus 1 equals 8 minus 3m. What people forgot to do is put that negative 3 to the 1 as well. So minus 3m minus 3 over n plus 1. So you're going to get 2 equals 8 minus 3m minus 3. 8 minus 3 is 5. So I'm going to subtract 5 over here. So I'm going to get negative 3 equals negative 3m. Divide by negative 3, m equals 1. Now, please, you guys, for the diploma, always check your answer with the non-permissible value. M can't equal negative 1. It doesn't match, so it works. No. What 8m? Answer still 1, but I screwed it up. M. 2 equals 5m minus 3. Still get the same answer. I just messed it up. Oh, that was totally garbage, that answer, but this is good. M equals 1. Some people said m equals 0 when this happened. And I can see why I screwed that. 5 divided by 5 is not 0. It's 1. The whole, everything was out of 1. It's out of 20. No, like each part. So 6a would be out of 1 and b would be out of 1.
What about number 2?
Number 1 is out of 1. Number 2 is out of 1. Number 3a is out of 1. B is out of 1. 4 is out of 1. 5 is out of 1. 6a is out of 1. B is out of 1. Who wants to get hit in the head by a bottle? Ben. All right. The probability that Mrs. Lepp will fall. Yeah. 80 out of 87. The probability that I will not fall is what? 7 out of 87. Now, shh. When you're going from probability to odds, it's always good to get the probability in favor and not in favor, because then odds is really easy to do. So they want the odds in favor of falling. Odds in favor of falling means falling comes first and not falling comes second. How many times do I fall? How many times do I not fall? What should these total? Bam, done. I'm clumsy. What can I say? I just fall all the time. This actually should have been the real probability of me stubbing my toe when I'm pregnant. I think my feet grow. Both times I was pregnant, I stubbed my toes like, well, I don't think, okay, arranging the word cooking, what's the probability the word starts with a consonant and ends with a vowel? So it's the word cooking. That's for the top and the bottom. C-O-O-K-I-N-G. So no matter what you do, you're going to have to divide the top and the bottom by 2 factorial because of the O's. So the top starts with a consonant, ends with a vowel. So we have 7 letters. So the consonants, there are 4. Then it ends with a vowel. There are 3. Then it's 5, 4, 3, 2, 1. But then you have to divide by 2 factorial because you always have to do that when the word has double ups or triple ups. That is just the top. That is literally the ways that you can rearrange this word when it's starting with a consonant and ending with a vowel. Then you have to divide by the total no restrictions. So on the bottom, you have, the only thing you have is you're arranging the word cooking. Then after that follows the probability of, right? So the bottom is rearranging the word cooking. How do you rearrange the word cooking? 7 factorial, so 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 2, because there's 2 O's. That's it. And you get 0.29. Yes. Okay, do this question. So you have a 4-digit code, repetitions allowed. That's the only restriction that is to the bottom. So on the bottom, you're going to have 10 times 10 times 10 times 10, right? Because there's no restrictions. It can be any number. On the top, it says it has to start with an even. How many even numbers are there? 0, 2, 4, 6, 8, 5. It has to end in an even, or end in an odd. 1, 3, 5, 7, 9, 5. And then there's no restrictions on your middle ones, and they can repeat. So it's 10 and 10. So it's going to be this. So mutually exclusive means no overlap. Not mutually exclusive means overlap, right? So we're going to do some questions. Choosing a marble from a bag of 7 blue, 3 green, and 1 orange, not 10, that's 1 orange. What is the probability of getting a green or a blue? So you're choosing a marble. What's the probability of getting a green or a blue? The very first thing you need to ask yourself is it mutually exclusive or not? If it's not mutually exclusive, you have to subtract the overlap. So, green or blue, are those mutually exclusive events or not mutually exclusive? Is there overlap between a green or a blue marble? Are there any green-blue marbles? No, so it's mutually exclusive. So you're going to do 3 out of 11 green plus 7 out of 11 blue is 10 out of 11. That's it. Now try number 6. There's 52 cards. What's the probability? I'm going to pull out one card. What's the probability of getting a red or a 10? Try it out. Okay, are they mutually exclusive or not? Red and 10. Not, because there's 2 red 10s, right? So then we have to do the probability, probability of red or 10 equals the probability of red plus the probability of 10 minus the probability of red 10s. So there's 26 out of 52 reds. There's plus 4 out of 52 10s minus the 2 red 10s, 2 out of 52, equals 28 out of 52. Then independent and dependent, this comes into effect when you have independent is when they say replacement. So that's when you're taking 2 events. So I'm taking out 1 card and then I'm taking out another card. Or I'm taking out 1 marble and then I'm taking out another marble. Whereas mutually exclusive and non-mutually exclusive is you take out 1 marble, what's the chance it's blue or black or something like that? Okay? So independent also can be a spinner, die, coins, anything with replacement. Dependent is when they depend on each other, so that's whenever you don't replace it. So you take out 1 card, you hold it in your hand, you now have less cards in here, right? So that's when you have that dependent, because now this card is dependent on whatever the heck you're holding in your hand over here. You deal with independent and dependent when there's an and between them, okay? So we're going to look at this one. So it's roll 2 dice. What's the probability that there's a sum of 7 and a sum less than 4? So remember I told you when you roll 2 dice to always do an array. So I did the array here. So you do that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and you do the sums. So there are no sums that are 7 that are less than 4, right? So there's no overlap, which you don't even have to worry about because it's an and, correct? Anyways, you'd go 6 out of 36 times 3 out of 36, and it'd be 0.01. My choice of just showing this was, don't forget, if it's sums of 2 dice, to always do an array. It's a lot easier to see all the different options. Okay, I want you to try this last one here. So, 1 second. So I want you to try these 3 options. These 3 options where one of them I'm going to say with replacement, and then do these 3 with replacement, and then do them as if they weren't being replaced. Okay? So probability of Jack and a Queen with replacement, probability of Jack and a Queen without replacement. 2 in a red with replacement, 2 in a red without replacement. King and a king, king and a king. Okay? Try them out. Okay. Jack and Queen with replacement. So it's going to be 4 out of 52 times 4 out of 52. Even if I used one of them, it wouldn't matter. And then you just times and get your answer. Without replacement, it's going to be 4 out of 52, but now I'm holding a Jack in my hand. So does that affect the Queens? No, I still have 4, but it affects my total, 51. Do the King and the King next, and do the 2 and the red last. Okay? So King and a King. With replacement, it's going to be 4 out of 52, and then 4 out of 52, because it doesn't affect it. It's going to be the same probability, because I take out a king, get one, put it back, take out another king, right? Same equal chances. But without replacement, it's 4 out of 52 the first time, but now I have a king holding a king in my hand. So it's going to be 3, because I have a king in my hand, and 51, because I have a king in my hand. 2 and a red with replacement. 2 is going to be 4 out of 52. Red is 26 out of 52, but now you have to watch. I've never seen the without replacement on this particular one with reds or blacks, because it makes it a little more harder. So you'd have to do cases. So if you have a 2, 4 out of 52, and a red, it would be 26 out of 51. But that would be if this card wasn't red. If I took out a 2, if I pulled the 2 out the first time and it wasn't a red card, I'd still have 26 red left, right, out of 51. But I have that case, or I have the case where I pull out a red or a 2, but now it's actually a red card, correct? So how many would I have left? 25 out of 51. I've never seen this. I'm just showing it to you. I've never seen it on the 30-2. I'm showing it to you because sometimes they do crazy things. So you'd have to have cases. You have to have a case where that 2 is a red, or a case where the 2 isn't a red. Okay? But like I said, I've never seen something that hard.